Hi everyone, my name is Gus Campbell. This is my submission for Lab 1. Let's get started. So for introducing the lab, for Lab 1, also called charge tapes, we're tasked to demonstrate the movement of charge through contact through pieces of clear tape. As we learned about charge / polarization, the lab intends to use household objects to show an important property of matter / electricity. There are two main concepts for this lab, one being the idea of motion of charge by contact and the idea of conservation of charge. Getting into the lab itself, these are the materials that I ended up using. I used a measuring tape that went down to millimeters, and then there's that roll of plastic or clear tape there. Going into the details of the lab itself, this is kind of how we make the U-tape, which is what I refer to from this point on, by taking a piece of base tape, sticking another piece of what we're going to call U-tape on top of it, and then as you rip it apart, it leaves the mobile charges, when in this case it's the electrons, to the bottom of the base tape, which creates the top tape being positively charged, which we will explore later on. To explore the fact that it is positively charged, we wanted to create a negatively charged object just to see how it would react. In this case, we took a plastic pencil, we made it negatively charged by rubbing it against a piece of cloth, and we see how they interacted. And in our case, we did get a pretty noticeable interaction between the pencil and the piece of tape. It was an attractive response, which would imply that the charges are different, and we know for a fact that the pencil is negatively charged. If the U-tape was also negatively charged, it would have repelled the pen, but we got the results that we wanted there. We could also assume, the U-tape could be neutral. In that case, it would also attract, but it wouldn't be quite as significant. After the polarization, it wouldn't have such an attractive force on it. This is how we set up the experiment itself. Now, going into the experiment, we are making a couple assumptions. The first one being, the experiment itself is we made two pieces of U-tape, and we're trying to make one float above the other through the repelling forces. The assumption that we're making is both tapes are charged the same, as we made them the exact same way. They're both 20 centimeters across and then 0.2 grams in mass. And then the other assumption is that we can treat the charges on the tapes as point charges in the center of the tapes due to the uniformity across. So going into the experiment, we ended up getting about the U-tape on top floated above the U-tape on bottom, about 2 millimeters high. They started to see, some kind of like a repelling force around 3 millimeters, but it was a pretty significant float above, and 2 millimeters is what I got in my testing there. So moving into the calculations itself, I want to draw a free body diagram. First off, we can assume there's no momentum on the tape above that was floating, so we can assume that the acceleration, the net force, was 0 on the top tape, which would imply that all y components up were equal to all the y components down. In our case, I was a little concerned that the force of the polarization from the book and the box that was holding up the tape was going to have some kind of impact, but I think those forces were small enough that we consider them negligible. So really it was just the force of gravity against the force of the repel of the book. Here in my calculations, I ended up getting 1.962 for the the gravity force, a distance of 0.002 meters. And then through my calculations here, I ended up getting 2.953 times 10 to the negative 8 newtons was the charges on both pieces of tape. And then to the right there, you'll see the equation that I used to find that, and we'll go ahead and revisit that in the code shortly. I apologize for the poor pictures, but moving on. So going into the code, a lot of the code was just copy and pasted from lab 0 and then updated to fit this lab, including some lab specific constants. Then we run the code. We get our model here where the red sphere on the bottom is the bottom U-tape, the blue sphere on top is the top U-tape, as we are assuming that they can be shown as point charges in the middle, the orange arrow being gravity, and the red arrow being the repelling force from the bottom U-tape. As you can see on the bottom here, the results were the same. I also got 2.953-ish times 10 to the negative 8 newtons. And then above here is just some things for me, some proving physicality. I wanted to point out some last questions here. If the electrons had positive charge, the protons had negative charge, none of the calculations would have changed. It would have been the same repelling force, which would have been negative charges repelling other negative charges versus positive repelling positive. And then also, I did make the comment that you really had to be careful with how you handle the tape. I made many tapes neutral by overhandling them and having the charges rush, and the mobile charges rushing into my body and into the floor. rendering them pretty much useless for our experiment. So in the end, I think I got some pretty accurate results. I attempted the experiment a couple different times over, recreating the tape, making sure everything stayed nice and charged. I'm pretty confident about the 2-meter float, and the results and the charge on both seems to fit the same bill. I appreciate your time. This has been Gus Campbell. Have a great day.